All right, lesson 7.5, properties of trapezoids and kites, part 2. All right, a kite is quadrilateral that has 2 pairs of consecutive, so right beside each other, consecutive, congruent sides. So instead of being opposite from each other like a parallelogram, the congruent sides are right next to each other. They're touching, so they share a vertex. Okay, so as I just said, opposite sides are not congruent. Okay, 2 sides right next to each other will be congruent. So I'm sure you've all seen a normal kite, but it would be something like this. Okay, so we have these 2 consecutive sides are congruent, and then these 2 consecutive sides are congruent. All right, the kite diagonals theorem says if a quadrilateral is a kite, then its diagonals are perpendicular. Okay, so we're going to draw another kite. Okay, its diagonals then. One line's going to go that way. It's going to go that way. So in kite, A, B, C, D, BC and BA would be congruent, CD and AD would be congruent, and the diagonals would form a 90-degree angle. So AC would be perpendicular to BD. Now, I want you to think about this because they're going to give you a question like this, and they're going to tell you, let's just name this E. They're going to tell you BE is a certain amount and CE is a certain amount. What's BC? Well, anytime you have a right triangle, if they're trying to find one of the sides, do the Pythagorean theorem. Okay, they try to throw it into every single kind of question, so watch for it. If you have a right triangle ever created, look to see if you can use the Pythagorean theorem. All right, so that's the diagonals theorem. Then there's also a kite opposite angles theorem. And it says if a quadrilateral is a kite, exactly one, so just one pair of opposite angles are congruent. Okay, so D again. We know BC and AB are congruent. We know CD and AD are congruent. Angle C and angle A are going to be congruent. So angle A is going to be congruent to angle C. But, very important, angle B is not congruent to angle D. Okay, so only one set of opposite angles will be congruent. Alright, we're going to find the measure of angle D in kite DEFG. DEFG. E is 115, G is 73. Okay, so because we know all kites have two congruent opposite angles, and we know that angle E is not congruent to angle G, then angle D must be congruent to angle F. So therefore, we can name those both X because they have to be the same. And we have a quadrilateral, so we know that all the angles add up to 360. So we have X plus 115 plus 73 all should equal 360. 2X plus 188 equals 360. 2X equals 172. So X equals 86. And we named angle D X. So therefore the measure of angle D and the measure of angle F have to equal 86 degrees. Okay, right here, I'm going to give you a handout. It's the special quadrilaterals on page 637. So leave this space open so you can tape or glue that in there. All right, what is the most specific name for quadrilateral ABCD? All right, we're gonna draw this. A, B, C, D, and we have some diagonals. And we're told those are congruent. We're going to call the intersection E. We're told those are congruent, and that is congruent to that, and this is congruent to this. Okay, that's all we know. So every time, please don't go by the looks, right? You can't go by what it looks like. So what do we know? If AE is congruent to EC, right? We knew that. And BE is congruent to ED. They told us that. Then the diagonals are bisecting. Okay. So ABCD is a parallelogram. By parallelogram, diagonals converse. So if I gave you the two lines, you can see they're bisecting, then you know that it's a parallelogram. Okay, but we don't know the angles. The opposite angles are congruent, but that only means that the BC and AD are parallel. So that's only telling us, again, that it's a parallelogram. Okay, we don't know 90-degree angles. We don't know side lengths. So I'm just trying to think through it. If we know those, I'm just wondering if we could actually prove all sides congruent by using the little triangles that are created. Yeah, all right, we'll talk about that in class. You guys can tell me what you think. Do I want that? Yeah. Okay. So that's the most we know right now, but let's talk about it further. Parallelogram. Okay. All right. Actually, let's turn this over. At least you don't have to. I want more room. Okay. In trapezoid, PQRS, PQ is parallel to RS, and MN is the mid segment. Okay, if RS equals 5 times PQ, what is the ratio of MN to RS? Okay, so that's an interesting one, right? That's a little different than what we've seen. Draw what we know. So we're going to draw a trapezoid. Okay, so we have PQRS. We know PQ and RS are parallel, so that's why I made those my two bases. And we know MN is the mid segment, so we need to draw that. Okay. And we know that RS is equal to 5 times PQ. So we're going to make PQ represented by X, and then we're going to make RS represented by 5X. Okay, everybody with me on that? So anytime they give you that type of information where they're just a side in terms of the other side, one of them has to be an X, and then you can label the other side based on that. All right, so what do we want to know? We want to know the ratio of MN to RS. So we need MN. So MN is going to equal half of PQ plus RS, right? Okay, that's just the definition of the mid segment. So let's plug in what we know. So MN equals 1/2, PQ is X, RS is 5X, MN equals 1/2, 6X, so therefore MN is 3X. Okay, so we can label MN 3X. Now, what did they actually want? The ratio of MN to RS. So MN was 3x, RS was 5x. Everybody with me? Okay. I'm going to set up in fraction form because that then helps us to see, oh, you know what? Those x's are going to cancel each other out. Therefore, the ratio is 3 to 5, or you could write it 3 to 5. Okay, so still using the same things, same properties that we learned. They just kind of put it in a different format.